Hello, my dear little warriors. Welcome back. In this video, we shall see a very important question which has been regularly asked in CBSE Class 10 board exams. They would ask either prove root 2 as irrational or root 3 as irrational or root 5 or root 7 as irrational. Whatever may be the question type, whatever may be the number which is asked to be proved as irrational, I will teach you five simple steps. Just use these five steps on every problem so that you can solve this problem very easily. Okay, shall we see how we are going to solve this? Let's go. Now, before we solve these types of problem, first we should understand what are rational numbers and what are irrational numbers. Rational numbers. Rational numbers are those numbers which can be written in the form a by b, where b is not equal to 0, and is a by b is a fraction or a ratio. This ratio, you can see, it has come from this word rational. The first five letters are ratio, and rational numbers means ratio of two integers. Basically, it's a fraction, and it can also be whole numbers, because whole numbers here 5 can be written as 5 by 1 or 0 by 3, but not 3 by 0, because the denominator b is not equal to 0. And also it can be fractions like 1 by 2, 3 by 4, and minus 7 by 8. There are also decimals that terminate, like suppose if you divide 1 by 4, you can get an answer 0.25. This is a rational number. 3 by 4, 0.75, it's a rational number. However, there are decimals that keeps repeating, like if you divide 1 by 3, you get 0.3333. It keeps repeating. Such fractions are also known as rational numbers. Irrational numbers are those numbers that cannot be expressed as a simple fraction of two integers. Here, irrational number cannot be written in the form of a by b. However you try, you will not be able to write in the form of a by b. Their decimal representation, they go on forever without repeating any pattern. Suppose you want to find, suppose examples for irrational numbers are root 2, root 3. You want to find the value of root 2, it keeps on going 1.77 something or 1.4 something something, 1.41421. It keeps on going, and the decimal numbers are not repeated. That's why these are called as irrational numbers. Same thing goes for root 3, root 7, root 11. The decimal numbers for these, the answer for these, they keep on going, they don't stop. Also, they don't repeat. Same thing goes for pi and epsilon, etc. Pi actual value is 3.141592 something, but even pi also does not stop. It keeps on going forever. So such numbers are known as irrational numbers. But when you take pi as 22 by 7, because in some of the mathematics problems or in physics problems, you will be told to use pi as 22 by 7 instead of actual value of pi. Okay, in when you are using pi value as 22 by 7, that value is actually a rational number, that is not an irrational number. 22 by 7 or pi being 3.14 is of no matter for us now, because in this question we need to prove root 2 or root 3 or root 5 as irrational. So we will solve one. Basically, I will solve root 3 as irrational using five simple steps. You follow the same steps to prove root 3 and root 5. You should be able to do. Even if they give you root 7 or root 11, you can use the same simple steps and do it. To prove root 3 as irrational, we will do in five steps. In step number 1, we shall assume root 3 as rational. So step number 1 is assumption that root 3 is rational. If root 3 is rational, then root 3 can be written of the form a by b, where b is not equal to 0 and a and b are integers. Examples for rational numbers are, you can take 4 by 7 or 11 by 9, etc. So these are basically, for example, I have given. So a by b is an integer. They have no other common factor apart from 1. Hence these are called as co-prime numbers. Co-prime numbers. That means they will not have any other common factor apart from 1, and such numbers are called as co-prime numbers. Step 2. Step 2 is you square both sides. So it is squaring. When you square, root 3 is equal to a by b, you will get 3 is equal to a square by b square, that is equal to 3b square is equal to a square, or b square will be equal to a square by 3. This is step number 2. Step number 3. Step number 3 is using theorem 1.2. Using theorem 1.2. As per theorem 1.2, if a prime number divides a square, then that prime number will also divide a. Okay, for example, here b square is equal to a square by 3. So if 3 divides a square, then 3 will also divide a. The meaning of that is 3 dividing a square. So a should be something like 3 into some integer. We take that as k. A is equal to 3 into k. Suppose you put that integer value as 5. So a will be 3 into 5 will be 15. Okay. So a square will be equal to 2 to 5. So 15 can be divided by 3 and 2 to 5 also can be divided by 3. That is the meaning of that. So here we will have value of a is equal to 3k. How you got 3k? I just explained here. Okay. So this is step number 3. Step number 4 is substitution. Step number 4 is substitution. What we will substitute? Substitution. We substitute a is equal to 3k in 3b square is equal to a, which is in step 2. So this one will become 3b square is equal to 3k the whole square. That implies 3b square is equal to 9k square. 3 times. So b square will be equal to 3k square, or k square is equal to b square by 3. Now what we are getting from this? We are seeing here also, if using theorem 1.2, if 3 divides b square, then 3 will also divide b as per theorem 1.2. At the end of step number 4, we find a is also a multiple of 3, and so we are getting b also multiple of 3. Therefore, step 5 is contradiction, or wrong assumption. Because we assumed root 3 is rational, therefore we wrote root 3 in the form of a by b, where they don't have any other common factors apart from 1. They are co-prime numbers. But here we find a is also a multiple of 3 and b is also a multiple of 3, and they share a common factor 3, which is contradicting our assumption. Therefore, since our assumption was wrong, therefore we can say root 3 is irrational. Hence proved. Here we have proved using 5 steps root 3. You can use the same 5 steps and solve root 2 or root 5 or root 7 or root 11, and the answer will be more or less in a similar fashion. Okay, you try and see if you are able to do it. In case you are not able to do it, you are stuck, just leave a message. I'll be very happy to reply. Okay, thank you so much. Hope you understood this video. See you in the next video. Thank you.